Hi everyone, in this video we have three piecewise functions and you have to find the derivative at a given x. So in the first function we have x squared plus x plus 1 when x greater than or equals to 1. And secondly we have 3x when x less than 1. And the first question you have to find f prime of 10, and as you know, as 10 you have to choose the correct interval, and 10 is greater than 1, so this is the correct interval. So you have to find the derivative of the first function, then you have to plug in 10 in the derivative, and you will get 2x plus 1. This is the derivative of x squared plus x plus 1. Then this is when x equals 10, and this gives us 2 times 10, 20 plus 1 is 21. The second part, in part B, f prime of 1, but here we have different case because 1 is common between the two intervals, and as you know, x greater than 1 means 1 from right, and x less than 1 means 1 from left. So you have to pay attention for this note. You have to check the continuity, then differentiability for the common x. So before you start find the derivative at x equals 1, you have to check the continuity around x equals 1. And simply to check the continuity, what you have to do is to substitute x equal 1 in both functions you have. And you will get 1 squared plus 1 plus 1. And you have to check this is equals or not to 3 times 1. This is a simple operation, and this gives us that 3 equals to 3. Which means that f is continuous at x equals to 1. So you have to complete and find or check the differentiability around x equals 1. So since we have 1 common between two intervals, you have to find f prime of 1 from right. From right, it means from here, so you have to use this function, and you have to find the derivative and substitute x equals 1, and you will get 2x plus 1 when x equals to 1. So 2 times 1 is 2 plus 1 equals to 3. So this is the derivative of x equals 1 from right. Now you have to find f prime of 1 from left, and f prime of 1 from left means here we have 1 from left, so you have to use this function, and the derivative of 3x is 3, which means that f prime of 1 from right equals f prime of 1 from left. So f prime of 1 exists and equals to 3. So this technique we use it when we have x common between the two intervals. You have to check the continuity firstly, then you have to check the differentiability at a given x. Okay, if in the question that f is not continuous or discontinuous around x equal 1, no need to complete and find the derivative of the function f at x equals to 1. When f is discontinuous, this means that f is not differentiable at the given x. Now in part C you have to find f prime of 0. Now 0 is not common, but 0 is less than 1, so you have to use this function. So f prime of x is the derivative of 3x, which is 3. So f prime of 0 equals to 3. Now we'll go to the next function. In g of x we have the function x squared minus 16x when x less than 9, and we have square root of x when x greater than or equals to 9. And the first question is to find g prime of 0, and as you know, 0 is less than 9, so the first interval is the correct choice for part A. So you have to find the derivative of the first function, and the derivative of the first function is 2x minus 16. Then you have to substitute x equals 0. So 2 times 0 is 0 minus 16 is negative 16. So this is the derivative of the function g at x equals 0. Now in part B you have to find g prime of 9, and as you see, 9 is a common between the two intervals, and x less than 9 means 9 from left, and greater than 9 means 9 from right. So you have to pay attention again for this note. Since 9 is common between the two intervals, you have to check the continuity first, then you have to check the differentiability around x equals 9. So g of x, what about continuity? You have to plug in 9 and both rules you have in this function. So 9 squared minus 16 times 9, you have to check if it's equal square root of 9. In the left hand side, the answer is negative 63, and in the right hand side, square root of 9 equals to 3, which means they are not equal, and this means that f is discontinuous at x equals 9. So directly, no need to check the differentiability. Directly, f is not differentiable at x equals 9, which means that f prime of 9 does not exist. Now in part C, you have to find the derivative of g when x equals 9.5. Now 9.5 is not common between the two intervals, so you have to choose the correct interval. The correct interval is the second interval, because 9.5 is greater than 9. So you have to find the derivative of this function, square root of x. And as you know, the derivative of square root of any function equals to the derivative of the inside function divided by 2 multiplied by the same function. So this is equals the derivative of the inside function is 1, because we have x inside, divided by 2 multiplied by the same square root function. Then you have to plug in x equals to 9.5, and this is equals 1 over 2 square root of 9.5. Then you can use calculator to simplify this fraction. Now the third function is h of x, and as you see, h of x equals x cubed plus 1 over 16 when x less than half, and 3 over 4x squared when x greater than or equal to half. And the first question is to find h prime of 1, so you have to choose a correct interval. 1 is not common between two intervals, so as you know, 1 is greater than 1 over 2, so this is the choice for this question. So you have to find the derivative of this function. The derivative is 3 over 4 multiplied by the function, multiplied by the derivative of the function x squared, which is 2x. By simplifying, you can simplify. Divide by 2 equals 1, divide by 2 equals 2, and this gives us 3 over 2 multiplied by x. Since you have to find h prime of 1, you have to replace 1 in the derivative, and you will get 3 over 2 times 1, which is 3 over 2. Now the second question is the derivative of h when x equals 0.5. 0.5 is half, so x less than 1 over 2 means 0.5 from left, and greater than or equal to half is 0.5 from right. So this is a common between the two intervals, so again you have to use this note. Since 0.5 is a common between the two intervals, you have to check the continuity firstly, then you have to check the differentiability. So simply, if you want to check the continuity for this x, which is 0.5, you have to replace 0.5 in the two rules in this function, and you will get 0.5 cubed plus 1 over 16, and you have to check if this is equal the substitution of x in the second function, 3 over 4 multiplied by 0.5 squared. So calculate them, and you will see that the left hand side equal the right hand side, which means that f is continuous at x equals 0.5 or half. So now you have to check the differentiability, and you have to find f prime of 0.5 from right. from right from here. So you have to differentiate this function again, and the first derivative is 3 over 2x here. So we have 3 over 2 times x, and you have to replace x equal 1 over 2 or half, and you will get 3 over 2 multiplied by 1 over 2, and this gives us 3 over 4. So this is the derivative of the function h,